Welcome back to the shrine. The microwave is one of those center assets in the kitchen that nobody knows how it works. And it's a Saturday morning. This microwave doesn't work. It's a Frigidaire brand, and until I fix this, the air in the kitchen will stay frigid. Unless this works, nothing is gonna change. That is the microwave, when she turned it on, emitted a loud pop, and then the water in the cup, even after 5 minutes, did not change temperature. So that means the microwave is not emitting microwave energy. I'm not sure if I can fix this, but it's Saturday and the stores are still open. So if it's not working, I might be able to get a different one, which will restore the family peace, and the air in the kitchen will go from frigid to maybe warm or hot. So let's see what's inside. Let's take the cover off and see if something can be done to mitigate this issue. Had to put on some cut resistant gloves. The stainless steel shroud or cover is so sharp. Also wanted to show you this. Check this out. So there's 5 fasteners holding the case in place, and they are of 2 different types. Standardization. So what we got in here, this is the business end. I've been inside here before. My wife was annoyed by the beeping sound of the microwave. Every time, you know, the microwave finishes and then it keeps beeping until you pop the door open, and that just annoyed the heck out of her. So I went inside and I just cut the leads to the beeper here. There is a piezoelectric beeper which is not beeping anymore. Well, first things first, we need to make sure that it's unplugged. And next thing is discharge the capacitor. As far as the microwave goes, it's really simple. You got the magnetron here. This is a transformer. It's got 110 on the primary, probably 2000, 2500 volts on the secondary coil. And then down here, that guy is the capacitor. The capacitor will discharge over time, but if you just unplugged it, then it still stores energy. Now you can use one of these, but I highly recommend against it. As you can see, this is not insulated. This is insulated. So there's energy stored in a capacitor. If you touch it with something metallic, it's going to go through your body. It's not going to be the finest day of your life. So do me a favor, just use one of these nice insulated ones. And then you go, and then you're going to go and touch the 2 terminals here. Okay, just like that. Make sure you don't touch the frame in the same time. Just touch the terminals. You might see a small spark, and that should be it. So the first check we're gonna do is just unplug the magnetron like so. Bring in the measuring device, put it on ohms. So we're gonna go and measure resistance. We're gonna touch these 2. And you can see we should see something below 1 ohm, so 0.2 ohms. So that one checks out. That means there's a coil inside, some kind of filament, and that is the resistance there. So the next thing we're gonna do is clamp one of the leads to the ground. We're just gonna go and touch the leads on the magnetron. You can see it shows 0 mega ohm. Basically there's no conduction, so neither of these conducting. So the magnetron checks out. The next thing we ought to check is the capacitor. So for that I'm gonna go and remove the lead from the capacitor. I'm gonna set this to capacitance. Okay, so that's diode, and then we're gonna push the mode button, and you can see it's capacitance now. That's the orange one, and it shows nanofarad, which is capacitance. So we're gonna go and attach the lead just like that. It shows 1033 nanofarad. So the capacitor has a marking on it on this side, and it shows 1 microfarad. So this would be 1.032 microfarad. So the capacitor checks out. We can also measure the resistance of the capacitor. If you don't have capacitance on your meter, just go to resistance. Okay, so that is the resistance between the blades of the capacitor. It's got 2 plates. So the next thing we can do is see resistance to ground. So the internal resistance should be 0, and resistance to ground should be 0. So you can see the cap checks out. The next thing we're gonna do is check the diode. For that we need to remove the diode. So here's the diode, and one error you can make is to try to measure the diode with a meter like this. So we can go to diode mode and we can clamp it like so. It doesn't matter at this point. We're gonna go forward and backward. Okay, so we are clamping it, and you can see it shows 0 resistance. It's not conducting in this direction. So let's try in the other direction. You can see nothing. So the diode seems to be faulty at this point. But the problem is with the measurement. These are high voltage diodes. You can have 12 volts of voltage drop on them according to the data sheet. So the way to measure these is the following. So what we're gonna do is we're gonna use a 9-volt battery. So we're gonna hook up the leads like so. And we're gonna switch the meter to voltage. Okay, so what we're gonna do is we're gonna measure voltage. We're gonna measure voltage on the battery. So you can see if I close this, we are showing 9.38 volts, negative or positive, doesn't matter at this point. So what I'm gonna do is hook up the diode like this, okay, and we are seeing 5.1 volts. So in this direction the diode conducts. Now if we swap the polarity on the diode, it's not supposed to conduct. And as you can see, the diode checks out. So this is a good diode. So as far as it goes, you can see everything checks out, but when it's plugged in, it is buzzing, and it's buzzing in a wrong pitch. So that tells me that all these switches are working properly, and then all these disconnects are working properly. So there's like a thermal disconnect here, and there's another one there, and then there are switches here. So when I plug it in, the light comes on, the turntable turns, the magnetron is buzzing, but it's not producing microwave energy. So at this point, I'd say it's safe to say that the magnetron is faulty. It checks out electrically, but something inside is faulty. So the next thing we're going to do is we're going to remove the magnetron and inspect the magnets on it, and maybe shake it to see if something rattles inside. And if nothing is wrong with it, I'm just gonna go and order a new one. So magnetron comes off like so. There's still one more item on the top here that needs to be unbolted. So here's the magnetron, and I'm shaking it. Nothing rattles inside. The magnets on it seem intact. So most likely this is the faulty component. So I'm gonna go look up the part number and just order a new one. $80, and 2 days later we got a new magnetron. As you can see, the part number is the same, 2M248J, and it's made by Toshiba. This one has no date code, unless the 1C26 is a date code, and then this one has a date code 2206, made in Thailand, both of them, and then the numbering is a little bit different. But this was the only one on Amazon available. It costs about 80 bucks, free shipping, and the only difference is that it comes with these tabs. So as you can see, on both sides they got these tabs, and the standard mounting bolts that don't go through these holes. So if the tabs are on, the magnetron is not going to fit into this slit here. There's a slit in the housing. So what I did is I just came in with a drill and I drilled these rivets out so that these tabs come off like so. So when if you're doing the same thing and if you're drilling it out, make sure that there's no chips adhered to the magnets. What I did is I masked this area so that the chips don't go in there and don't get stuck. But unless the tabs are on, you cannot really tell the difference between them. They are exactly the same. The cooling, the magnets, everything is the same. So what we're going to do is, of course, go ahead and install it, and then we're gonna go and test it. Just to be on the safe side, I went ahead and ordered diodes also. So I'm gonna go and replace a diode. I read online somewhere that is a recommended practice. This is also from Amazon, 5 diodes for 10 bucks. There you go, 5. And it's the same part number, so it says CL0412. So if you look at the diode, you can see the designation is CL0412, and then this RG910, that's probably date code or something along those lines. You can see the marking is the same. So this is the new diode. Here's the old one. You can see the new diode is basically the same as the old one. It's got a ring terminal, it's got a spade terminal here, and it's got the marking on the ring terminal side, which typically marks the cathode on any of the diodes. And this one says CL0412 RG008. This says CL0412 RG910. So that's RG910, maybe that's a plant or a date code or something along those lines. But I'm going to go ahead and install the new diode. The test of the rigidity of the ring terminal. You know what's coming. Put on my safety squints. I'd say that pass. Okay, the diode is installed back in its position. All it does basically just bumps up the voltage from whatever 2500 to 5000 volts. Just make sure all the connectors are connected back. Everything is connected back everywhere. And then we can go and do a test drive. To properly test it, we need some kind of liquid. So this looks perfectly good. There you go. Okay, first thing is plug it in. Light comes on. That's good. Shut the door. Do 30 seconds. So it's not arcing, it's not sparking. The light is running, the fan is running. It's got the old tone. The magnetron is not buzzing. That was really interesting. I was recording and I can see on my Sony camera microphone that it's flashing when the magnetron was on. So the magnetron is probably irradiating something this way and it's interfering with my microphone. Now I gotta put the cover back and make sure that no bad radiation comes out. So it's finished and this is warm. So it is working. It's a good working condition. Now, why do I do all this? You know, I can go spend 300 bucks, buy a brand new one, but I think this has a lot more life in it. And I only spend 90 bucks basically on the diodes and on the magnetron, and we'll go and have some fun with this, do a teardown video, look inside, see what's hiding inside. I'm gonna put the cover back on and position her in her place in the kitchen. Hopefully the Frigid Air is going to disperse in the house, since we know we have a working microwave. So thanks for watching. Hope you guys enjoyed the video. If you like it, give me a thumbs up, and if you like the channel, please don't forget to subscribe. See you next time. Bye.